Hello everyone, welcome to another session in the deep learning series. Today we'll actually take up an example network. We'll basically initialize the weights and bias with random values. We'll fix the input and output values, and we'll basically calculate the forward pass across each layer, and calculate the gradients, calculate the errors, and back propagate across the network as well. Right? I think we will consider the same network here. Whatever the network you see over here, we'll consider the same network. So this is basically your input layer, and this is your first hidden layer. So all of these weights, the all of these weights, basically I1 weights, basically all of these weights I1 J1, I1 J2, I1 J3. Similarly, the other weights as well will randomly initialize. And yeah, we'll basically consider the same network architecture. Hidden layer is basically, for this particular hidden layer H1, you have ReLU as your activation function. For your hidden layer H2, you have sigmoid as your activation function, and your output is basically a softmax layer, right? So over here, again, we'll sort of randomly pick the input values as well. So whatever input values you have, we randomly assign the input values. So this would be your, I would say this would be your input values. Your input is basically 0.1, 0.1, 0.7, and this is your node I to J weight matrix. So you have I1 J1, I1 J2, I1 J3, I to J1. So this is your node IJ, right? This is your node I to J. This is the node I to J weight matrix, and all of these values are randomly assigned. Okay. Then this is your node J to K weight matrix. Okay. So these values as well are randomly assigned. Next is your node K to L weight matrix. This is K to L, K1 L1, K2 L2, K3 L3. Right? So even these values are randomly assigned. Here this is the basic output, and here the error metric, error function which we're basically using is something which is called as cross entropy. So this is, I think if you remember, this is similar to what we had used in logistic regression as well. It's the same thing. So yeah, so let's start with the forward pass. So forward pass is where? Forward pass is now you have the input values. Now you're basically moving to the first hidden layer, right? So over here, what would basically happen is, consider this particular structure, right? So this is your layer 1. You're basically calculating H in one, H in 2, H in 3, H1 in 1, H1 in 2, so on. Right? So here basically what would happen is, you have your input values I1, I2, I3. You basically multiply. This is your randomly initialized weight matrix which we just saw. These are your again randomly initialized biases. You basically take a cross product of each one of these and add to your bias, correct? So that is basically what is your H1 in1, H1 in2, and H1 in3, right? Now after you get this, basically what you do is you pass it through your activation function. So the activation function for the first layer is your ReLU, and yeah, you basically take maximum of those values. This is basically what the first this thing is. So whatever values we get from output of activation function is basically our output 1, output 2, and output 3. Okay. So this is the first layer forward pass. Now basically what we'll move on to now is your layer 2. This is basically what the values is. So you have 0.1, 0.2, 0.7 as your inputs. These are your randomly assigned weights. These are your biases. So after you pass this is the values, and after since your activation function is ReLU, these are your outputs. Now we'll basically look at the layer 2, right? So layer 2 is nothing but now what you're basically doing is from H1 to H2. hidden layer 1 to hidden layer 2, your forward pass. Okay, and this is your input. I think for now, since the input to the hidden layer 1 is done, now our focus is basically on this particular layer. From this layer to this layer is what our focus is, correct? So again, it's the same. Conceptually, it's basically the same thing, right? Previously, whatever you saw, right? So these are your inputs. You multiply with the weights, add to your bias. After that, you basically pass it through your activation function. And so conceptually, it is the same. What would change is, so this one, right? This one for this layer, right? For this layer, this one is your input. And whatever weight matrix you're randomly assigned, you multiply with that and add your bias. Here, one point to note is the activation function has changed. Here, activation function is basically sigmoid. Right. Now we'll basically see a calculation of that as well. So now you can see, so H1 out 1, H1 out 2. So this is nothing but this is your input from the previous layer. This is basically output from your previous layer, correct? And that's what conceptually, if you basically understand the first two layers, right, it's the same only. Conceptually, nothing much changes, only the corresponding outputs you need to replace. You basically need to replace the values, that's it. And your activation is sigmoid. Sigmoid is 1 by 1 plus e power minus x. Correct. So previously, since it was ReLU, right? So ReLU, formula of ReLU is max of 0 to x. Whatever values you had, you just directly took a maximum of that. But over here, since it is sigmoid, you need to actually calculate your. You basically need to pass the inputs through sigmoid to get your output. Again, conceptually it's the same. You're just replacing it with your numbers. 1.4. These are the randomly assigned weights. These are biases, correct? And so yeah, so basically it's a basic matrix multiplication. You multiply this with this, this with this, this with this. Then you basically add the biases. So this is the value which you get after your initial cross product plus addition of bias. The next, you basically pass each one of them through the sigmoid layer, correct? Now you basically pass each one of them through the sigmoid to get your final output. And what this is, right, H2 output 1, H2 output 2 and H2 output 3 is what this basically is. This is basically output of your hidden layer 2, correct? Now basically what would happen is output of this hidden layer 2 is passed through your final output layer. Okay, so this now basically what you have calculated over here, correct? That is basically output of this. What you want is what we want is we basically want output of this final layer, correct? Now again the same thing. You basically take H2 output 1, output 2 into a randomly created weight matrix and bias, correct? So conceptually again, conceptually it's the same thing. Only thing is you need to change your values. So after you got your values and weights, you basically substitute it. These are your weights. So these are your weights and these are your values. So final one thing is, so this is your inputs. Now basically what you do is you basically pass it through your softmax function. So softmax, basically what is softmax is, this is basically softmax. Suppose you have 3 values, correct? Basically what you do is you take the exponential of the first one divided by the sum of everything, right? Because your 3 inputs, your input for softmax is basically this, correct? So input of this one, your input of softmax is basically this particular row, right? O in 1, O in 2, O in 3. So softmax of e to the power of O in 1 by summation of everything, e to the power of O in 2 by summation of everything, e to the power of O in 3 by summation of everything. That is basically what is this one, right? So now you have got your actual values. Now you basically what you need to do is you need to basically calculate your error or cross entropy. Since you're using cross entropy, you just calculate this. So it's nothing but if it is 1 log of that, if it is 0 1 minus log of the value. So this is basically the formula for cross entropy. Again all of these have been discussed in quite detail in logistic regression example. We can just directly calculate the value of your cross entropy, right? So this is the forward pass, right? So now basically what has happened is you have basically moved from here to here, here to here, here to input to H1, H1 to H2, and H2 to your output, right? So this is what is called as forward pass, right? Now I think now is where the main part comes in. Now is where the back propagation part comes in, right? So that's what I think we'll discuss in the next session. Thank you.